Hello and welcome to this video. My name is Haley and today we're going to be going over derivative rules. Okay, a couple of notation notes before we get into the actual rules. So d over dx in front of a function means take the derivative. F prime of x means that whatever is after the equal sign is the derivative of f of x. So, for example, if we have d over dx of x squared, this means take the derivative of x squared. F prime of x equals 3x plus 5 means 3x plus 5 is the derivative of f of x. Okay, so the first rule we're going to talk about is the constant rule. So basically this is just if you take the derivative of a constant, that's going to equal 0. We'll see why this is in a second when we talk about power rule, but just know, for example, if you had the derivative of 2,536, that's just going to be 0. So it doesn't matter if it's a number, doesn't have any variables attached to it, it's going to be 0. Okay, so the next rule that we're going to talk about is the power rule. And the power rule says that if you have x to some power n, then the derivative is the power times x raised to the power minus 1. So, for example, let's say that we were taking the derivative of 5. You might be confused as to how to use the power rule since it doesn't have an x raised to a power. However, it actually does. 5 has an x to the 0 next to it. Since anything raised to the 0 power is 1, therefore 5 is the same thing as 5x to the 0. So this is the same thing as saying the derivative of 5x to the 0. And now using our power rule, we see that the 0 comes down and then we subtract 1 from the exponent. But all of that is just going to be 0 since anything times 0 is 0. And that's why any constant, when you take the derivative of it, is going to be 0, since you always are going to be multiplying by that 0. Okay, so let's take a look at some more examples. Say that we were taking the derivative of 7x to the third. Well, according to power rule, the 3 is going to come down, and then we're going to subtract 1 from the exponent. So then we have 7 times 3, which gives us 21, and then 3 minus 1 gives us an exponent of 2. Therefore, our answer would be 21x squared. Okay, so let's take a look at another example. Find the derivative of f of x when it's equal to 6x to the third minus 9x plus 4. So when we're adding or subtracting like this, we're just going to take the power rule on every single term. So the first term, the 3 is going to come down, and then we subtract 1 from the 3 exponent. For the 9x, there's going to be a 1 that comes down, and then we subtract 1 from the exponent. And then 4, we know from our constant rule, is going to be 0, but I went ahead and wrote it out like we did on the previous example. So then we get 6 times 3, which is 18, 3 minus 1, so we get x squared. X to the 1 minus 1 is 0, so we get minus 9x 0, and then plus 0 since the 4 times the 0 becomes a 0, and so we're left with 18x squared minus 9 as our answer. So what you see on the screen right now are the typical exponential and logarithm derivatives used in calculus. So the general exponential and logarithm derivatives come from using the limit definition of the derivative to find the derivative. The special cases are actually the general rules in disguise. So if we apply the general log rule to natural log of f of x, we get the derivative of natural log of f of x is equal to 1 over f of x times natural log of e times the derivative of f of x. But the natural log of e is 1, so we just end up with the derivative of f of x over f of x. Then, if we apply the general rule for log to natural log of x, we get the derivative of natural log of x is equal to 1 over x times natural log of e times 1, which is equal to 1 over x when you simplify. Similarly, if the general rule for exponentials is applied to e raised to the f of x, we get that the derivative of e to the f of x is equal to e to the f of x times natural log of e times the derivative of f of x, which is e to the f of x times the derivative of f of x. And if we apply the general rule for exponentials to e raised to the x, we get the derivative of e to the x is equal to e to the x times natural log of e times 1, which just gives us e to the x. Okay, so let's take a look at the product rule. So the product rule says that if you have two things multiplied by each other, you take the derivative of the first one times the original of the second, plus the original of the first one times the derivative of the second. So For example, let's find the derivative of h of x equals 6x squared minus 7x plus 9, all of that times x cubed plus 4x squared minus 10x minus 3. Now, if we just had the power rule, we would have to multiply everything out and then take the derivative of each individual term, which seems like a lot of work. Luckily, we had the product rule to make things a little easier on us. So let's go ahead and label what is going to be f of x and what is going to be g of x. To match our product rule, let's have 6x squared minus 7x plus 9 be our f of x, and x cubed plus 4x squared minus 10x minus 3 be our g of x. The product rule says that we also need the derivatives of f of x and g of x individually, so let's find those derivatives using power rule. So for f of x, I'm going to get my derivative is 12x minus 7, and for my g of x, I'm going to get the derivative is 3x squared plus 8x minus 10. Now that we have all the pieces, let's put them all together. So our f prime of x is 12x minus 7, so we're going to multiply that by our g of x, which is x cubed plus 4x squared minus 10x minus 3, and we are going to add that to f of x, which is 6x squared minus 7x plus 9, times our g prime of x, which is 3x squared plus 8x minus 10. So that would be our answer. You could multiply everything out, but usually it's acceptable to just leave it as shown. However, it will depend on what your specific professor wants. So let's take a look at another example of using the product rule. So let's find the derivative of j of x equals e to the 2x squared times 4x to the third plus 7. So for this example, even multiplying out wouldn't help, since you still would have to end up doing the product rule, except you'd have to do it twice and not just once. So like before, let's label our different functions. So I'm going to say f of x is e to the 2x squared, and g of x is 4x to the third plus 7. Now it doesn't really matter which one you label as which, as long as you keep all your labels straight. So according to our exponential rules, our f prime of x is going to be 4x times e to the 2x squared, and by power rule, our g of prime of x is going to be 12x squared. So putting it all together, we get f prime of x, which is 4x times e to the 2x squared, times our g of x, which is 4x to the third plus 7, plus our f of x, which is e to the 2x squared, times g prime of x, which is 12x squared. And that would be our answer. Okay, so now let's take a look at the quotient rule. The quotient rule says that if you have something divided by something else, then on the top we're going to get f prime of x times g of x minus f of x times g prime of x all over g of x squared. So the top of the quotient rule is the same as the product rule, just with a minus sign instead of a plus sign. So that is just a helpful memorization tip. So let's take a look at an example. Let's find the derivative of h of x equals natural log of x over 2x. So I'm going to say that the natural log of x is f of x, and 2x is g of x. So our f prime of x is going to be 1 over x using our logarithm rules, and g prime of x is going to be 2. So putting it all together, we get f prime of x, which is 1 over x, times g of x, which is 2x, minus the natural log of x, which is our f of x, times g prime of x, which is 2, all over g of x squared, which is 2x squared. So doing some simplifying, we get that 2 minus 2 times natural log of x over 4x to the squared is equal to 1 minus natural log over 2x squared. And that would be our final answer. And if it's not too much trouble to simplify, I would go ahead and do it. But you definitely should simplify your answer if the question says to. So let's look at one more example for quotient rule. Find the derivative of j of x equal to 4x cubed minus 9x all over 5x squared plus 2. So again, I'm going to label, then find the individual derivatives, then plug it into my rule. So I'm going to say that 4x cubed minus 9x is f of x, and I'm going to say that 5x squared plus 2 is g of x. So using power rule, I'm going to find that our derivative of f of x is equal to 12x squared minus 9, and the derivative of g of x is going to be 10x. So plugging into the rule, I get that f prime of x, which is 12x squared minus 9, times g of x, which is 5x squared plus 2, minus f of x, which is 4x cubed minus 9x, times g prime of x, which is 10x, all over g of x squared, which is 5x squared plus 2 squared. And then I multiplied out the 10x with the 4x cubed minus 9x and left the 12x squared minus 9 times 5x squared plus 2 as well as the g of x squared. If the question says to fully simplify, they might want you to multiply it out and then combine like terms, but it really just depends on your professor. Okay, so the last rule that we're going to be talking about today is the chain rule. And the chain rule says that if you have f of g of x, then the derivative is going to be f prime of g of x times g prime of x. So let's take a look at an example to kind of figure out what this means. So let's say that we had the derivative of 3x to the third minus 6x squared, all of that to the 8th power. So similar to the product and quotient rules, we're going to label and take the individual derivatives, then put it into the chain rule. However, it can be a little confusing at first to figure out what should be labeled as what, but after some practice it becomes more clear. So typically when talking about the chain rule, there are two parts: the inside, g of x, and the outside, f of x. The inside usually refers to whatever is being raised to a power or inside the square root. The outside is usually the power or the square root. So in this example, the inside is 3x to the third minus 6x squared, since that is the function being raised to a power. The outside is the power of 8. To take the derivative, we leave what's on the inside the same and take the derivative of the outside function, then multiply by the derivative of the inside. So for example, if we're taking just the derivative of x to the 8th power, the 8 would come down and then we'd subtract 1 to get an exponent of 7. But since we don't have x on the inside, we're just going to leave the 3x to the third minus 6x squared. Then we're going to multiply by the derivative of 3x to the third minus 6x squared. So then we leave the first part the same, and we find that the derivative is 9x cubed minus 12x squared, and then that we can rewrite as x times 9x squared minus 12x times 3x to the third minus 6x squared, all raised to the 7th. And then I distributed the 8 to the 9x squared minus 12x to get 72x squared minus 96x times 3x to the third minus 6x squared, all raised to the 7th power. And that would be your answer. So this is our last example for the day. Let's find the derivative of y equals the square root of 3x squared plus 5. So let's rewrite it so it looks like something we're a little bit more familiar with. So I'm going to rewrite it as 3x squared plus 5 all to the 1/2 power. So taking the square root of something is the same thing as taking that to the 1/2 power. And now it looks similar to the last example. So our inside is going to be 3x squared plus 5, which is our g of x, and our outside is going to be our f of x, which is the 1/2 power. So then we bring the 1/2 power down and we subtract 1 from the exponent, and we're going to multiply by the derivative of the inside, which is 3x squared plus 5. So then when we subtract 1 from the exponent, we get negative 1/2, and when we take the derivative of 3x squared plus 5, we get 6x. And rearranging a little bit, I'm going to get 1/2 times 6x times 3x squared plus 5, all to the negative 1/2. And then 6x times 1/2 is going to give me 3x, and then that's going to be over the square root of 3x squared plus 5. Since if something is to a negative power, then that's going to flip it to the bottom, and the 1/2, like we said before, is the same thing as the square root. So our final answer is 3x over the square root of 3x squared plus 5. So that's it for this video. I do have practice problems located in the transcript that's in the description of this video if you would like some more practice with these concepts. I do have answers included in the transcript, but if you would like a more in-depth video on how to get to those answers, I can certainly do that. Just leave a comment letting me know. There are resources for UNT students also located in the description, like links to our website and the other services that we offer. I do hope this video was helpful, and if you would like to see more videos like this or on different topics, just leave a comment or reach out to us on social media and let us know.